Have you ever tried to get out of jury duty? About 25% of those called will find an excuse, work, poor health, travel, out of town, etc., to avoid jury duty, according to the source. If 12 people are called for jury duty, A. What is the probability that all 12 will be available to serve on the jury? B. What is the probability that 6 or more will be not available to serve on jury? C. Find the expected number, the mean, of those available to serve on the jury. What is the standard deviation? D. How many people in must the jury commissioner contact to be 95.9% sure of finding at least 12 people who are available to serve? Okay, for A here, before we answer A, let's go ahead and think about what X is, our random variable. So in this case, X equals the number of people who are willing to serve on the jury. Okay, so this tells us that our P here is not 25%, but rather 75% or 0.75, because the 25% represents those who will find an excuse. So it's the opposite or the complement of that particular probability or statement. And so that's what we got here. And we know n is equal to 12 people because we call 12 people. So that means our random variable x basically takes on the value 0 for 0 people willing, 1 person willing, 2 people willing, all the way up to 12. So it's any one of those possibilities there. And so for part A here, we're x. What's the probability that all 12 will be willing to serve on the jury? So x equals 12 here. So we're going to go to our calculator and input 12 because there are 12 jurors. 0.75 for our probability of success. And then what's the probability that exactly 12 will be willing to serve? Okay, and so we're going to read the number from B14. That's the probability. So there's not a very good chance of this happening. And so our probability is about 3.1%. So we could say essentially about 3.2% chance of exactly of all 12 will be available to serve on the jury. All right, B here. What is the probability that 6 or more will not be available to serve on the jury? And the way I'm going to think of this is define my random variable differently this time. This time, X is the number of people who are not willing to serve on the jury. Which means that I'm going to change my P now to 0.25. N is still 12. Because there are 12 people we called. All right, and we're looking for the probability that 6 or more. Which means it's the probability that X is greater than or equal to 6. Okay, so we still have 12 here, but I'm going to replace P with 0.25. And so the probability that it's 6 or more, we put the value of 6 here. And so 6 or more will correspond to the cell in E9. Or alternatively, you could add the values from 6 on. And so we get a probability of 0.0544. And so we can say there is about a 5.4% chance at least at least 6 people willing to will not be available. To serve on the jury. Okay, so for part C here, we're asked to find the expected number, mean, of those available to serve on the jury. And what is the standard deviation? Okay, so to find the expected value, we have to use the formula that the mean mu is equal to n times p. Okay, and to find the standard deviation, we have to use the formula n times p, the square root of n times p times q. Okay. And so that we're finding the expected number of those willing to serve. So for this particular case, the mean mu, it's just going to be 12 people times 0.75. And multiplying that out gives us 9. And so this calculation could have been done using our calculator here. Just make sure you replace this back with 75 here, because originally it was probably 25. Oops, 75. And then the expected number is the 9 here. Okay, so let's interpret this. This says in the long run, if you call 12 people many times, the expected number of people willing to serve is 9 people. So if you did this many times, calling 12 people over and over again, and actually they're willing to serve, then you would expect about 9 people to say yes in the long run. All right, the calculation for the standard deviation is similar. This time it's equal to the square root which would be the square root of 12 times 0.75 times q, which is 1 minus our 0.75 to get 0.25. Okay, and so what is this value? Well, let's look at the calculator. We see that it's about 1.5. Okay, so let's interpret this value as well. So basically in the long run, on average, the number of people willing to serve on the jury deviates about 1.5 people from the expected number of people willing to serve Let me just say that in the long run, on the average, the number of people willing to serve on the jury deviates about 1.5 people from the expected number of 9 people willing to serve on the jury. All right, question D here. How many people must the jury commissioner contact to be 95.9% sure of finding at least 12 people who are available to serve? All right, so to answer this question, we are essentially trying to find a value for n that satisfies the following statement. In other words, we want to be able to, that a random variable is less than or equal to, greater than or equal to 12 people. And we want this probability, we want to be confident enough. How confident? We're told we want to be confident, 95.69% confident. So we want this to be greater than or equal to 0.956, right? Let me double check that. No, I'm sorry, 95.959. In other words, basically 96% confident, okay, that this statement is satisfied. So we're looking for the random variable x such that x is greater or equal to 12 to exceed 0.59. So we want to pay attention close to E9 here, E9, this number here, and we want this to exceed 0.959. 0.959. Okay, 0.959. All right, we need to at least call 12 people. So right now there is not a big enough chance, right? There's only if we only call 12 people, then we know that to get 12 people willing to serve, there's about a 3% chance. So what we're going to do is adjust or vary this in here. So in here, we'll change to 13. So you can see that the probability of x being at least 12 is now about a 13% chance. We need to exceed that. So 14 doesn't do the job. 15 doesn't do the job. Let's go up to 18, see if that works. Almost. 19's close. How about 20? And then 20 does the job, because here you can see that the probability that x is greater than or equal to 12 is 0.959075, which exceeds that number there. Okay, so what do we say then? The jury commissioner should call at least 20 people. 20 is the minimum to be 95.9% confident that at least 12 people will be willing to serve on the jury.